Happy Sunday afternoon, everybody. This is a live emergency briefing as we're going to be talking about the severe weather threat in North Texas into southern Oklahoma. And I do think that there is a small but non-zero chance of a tornado across the red circled area there between about 10 p.m. and 5 a.m. That's the mode that I've circled there, the convective mode that I do expect to develop just a little bit ahead of that front. That'll be in the northern part of that instability axis where there is some surface-based instability. And the chances have actually increased for tornado potential since the last time that we did this briefing. And I do expect supercells to develop near the Texas Hill Country to the southwest of DFW, probably at about 10 p.m., 10 to 11 p.m., and they're going to race off to the northeast. And there is a little bit of surface-based instability out here, too, especially just to the west of the DFW Metroplex between about 10 p.m. and 1 a.m., even a little bit after that, along the Red River region to the northeast of Dallas and to southeastern Oklahoma. Definitely could be a chance of a tornado. Then you get this elevated convection that fills in along that surging cold front there. But it's really this mode that develops out ahead of that front that we're keeping a close eye on. That does have a chance of producing those tornadoes. Here you can see those evolving at about 5Z. That's about 10 p.m. there. So it is going to be an after dark type of a severe weather event. Right now you're socked in fog there in North Texas, definitely getting dominated by that very dense fog just ahead of that to the north of that warm front as rapid moisture advection is well underway. Dew points in the 60s, even some 70s dew points there right along the Gulf Coast in southern Texas. And a lot of that is because the sea surface temperatures in the western Gulf are a lot warmer than the rest of the Gulf, the north-central Gulf of Mexico as well. A little bit moderated there from the hurricane season, some below normal sea surface temperatures, especially in the north-central Gulf of Mexico. But the western and the southwestern Gulf have deep dew points, really warm sea surface temperatures, and that's allowed upper 60s dew points to propagate northward along the Rio Grande Valley, and that moisture advection through the state of Texas has led to fog during the daylight hours. But this is going to be an after dark type of a severe weather event. This is at 19Z, so really what I want to do here next is compare this dew point map that you see here. This is the HRRR forecast dew points, the 12Z HRRR for 19Z, which is about right now, about 1 p.m. Central Standard Time. So we're going to compare this to the actual surface map and see just how well that moisture advection is underway. But first I want to give you a sneak peek at the convective evolution expected. You can see just a lot of warm advection showers out here, a lot of fog. You could definitely tell even on the HRRR composite reflectivity that these are associated with isentropic lift, basically warm air lifting up and over stable air at the surface. Warm advection precip. You can see these showers beginning to bubble at about 3 p.m. here across the Dallas-Fort Worth Metroplex as well. A clear sign of major warm advection. You can see that in the low-level jet that's starting to increase here, starting to percolate at about 3 p.m. It's a couple hours from now. That low-level jet begins to increase above 30 knots. And right at the nose of that developing low-level jet, you get a couple elevated showers that are happening there, nested within that fog. But during the day, this low-level jet is going to continue to increase. And then upon trough ejection after sunset, that's when the low-level jet really ramps up. But you're going to have a lot of these warm advection showers out here. And even though I do think there is a small non-zero chance of a tornado across North Texas into southern Oklahoma, there are definitely some things that could go wrong with this setup. But this is at 5 p.m. Central Time, and you can already start to see some convection starting to develop out there across western Texas. And really quick, we'll just run through this hour-by-hour HRRR forecast composite reflectivity. Off to the east, you can still see these warm advection showers. The trough, though, is starting to eject across West Texas by this time. This is right at about sunset, about 6 p.m. out here across West Texas. Definitely looks like some storms that are developing out there in the southern Texas panhandle. We look at a sounding here, and you can certainly see a stout area of stable air at the surface. So those storms are elevated despite these very strong wind shear profiles, changing from easterly over to southwesterly as that low-level jet intensifies. This is just a big-time frontal inversion there. These are going to be elevated over a surging cold front out here in the Texas Panhandle. Here you can see that cold front. So there is some elevated convection that develops out there in the southern Texas Panhandle that could look interesting. But the threat for surface-based supercells is going to be late. That's going to be after about 10 p.m. This is at about 7 p.m. Central Standard Time. You can still see this elevated convection developing here in the southern Texas Panhandle over top that cold air. There, definitely some stable air at the surface. These are obviously elevated. You can still see the warm advection showers from the DFW Metroplex up through the Red River region. But this elevated convection developing out here in western Texas by this time, which is 7 p.m. Central Standard Time, shows that the trough is ejecting. And that convection, elevated convection, increases in coverage out here. And it's this area down here into the Texas Hill Country to the west and maybe even to the southwest of DFW that we really need to watch for the development of surface-based convection and that mode of convection and storms that look to have the greatest potential to produce tornadoes and severe weather. This is at about 3Z, 9 p.m. Central Standard Time out here. You can start to see some more robust convective towers out here. The elevated storms that developed over the Texas Panhandle are starting to congeal into an MCS by this time. But it's this area, this renegade mode of convection that's going to develop out ahead of that front on the northern edge of that surface-based instability axis that definitely does have a chance to get some supercell storms in there and maybe even some that could drill down to the surface. The wind shear could be quite strong out there. This is at 10 p.m., so this is really when that window begins, when there could be a tornado threat off to the west of DFW out here, and that convection extends north all the way into southern Oklahoma. Let's look at the low-level jet really quickly. This low-level jet is starting to increase by 10 p.m. That late ejection, late arrival of the trough, and as well as the unfavorable shape as it's kind of shearing out as it ejects from the southern Rockies are leading to a low-level jet axis that has some holes in it here, but it's starting to increase by about 4Z. Then you go to 5Z, and look at it ramp up here right up against that shortwave trough and in the vicinity of that convection that's developing to the west of the DFW Metroplex. Low-level jet by this time beginning to accelerate above 40 knots. And there you can see those storms. This is the mode that we're going to be watching this evening. This is at about 10 p.m. Central Standard Time, between 10, 11, 12, and then after that along the Red River and into southeastern Oklahoma. Southern edge of this definitely does have the potential to be surface-based. You can look at the sounding. And it does show a marginal tornado threat. The photographs are quite favorable as that low-level jet accelerates to above 40 knots, as you can see there. But the sounding definitely has some shallow, stable air right at the surface, 60 over 59. Above that, you've got steep lapse rates in the mid-levels of the atmosphere. Nice dry punch up there, above 500 millibars as well. A little bit of a warm nose that needs to be eroded, kind of a capping inversion there for these to develop. But that's the mode that I'm most interested in tonight. And then you can see it kind of starts to peter out as it lives off to the northeast toward the Red River into southern Oklahoma. Looks like the HRRR is hinting at supercell structure there right along the Red River at about 11 p.m. Central Standard Time. And then that complex lifts off to the northeast into southeastern Oklahoma. And then the original elevated storms that are developing in the southern Texas Panhandle are moving east across northwest Texas. These are definitely elevated up here. The low-level jet is beginning to veer by this time. But as it shifts to the east, it may even catch up with that surface-based instability axis and kind of lead to a second wave of severe weather that could come through the Dallas-Fort Worth area. But I do think that for the most part, that low-level jet is shifting off. Well, there it is. It's hanging tight right along that convective line back into North Texas. So quite a bit of wind shear ahead of that next convective line that comes through. Favorable soundings as well for a tornado threat. That low-level jet even increases the temperatures a little bit more behind that next renegade band of supercells that forms. But look at how it holds that relatively backed low-level jet right up against that convective line. And this is at 9Z. So this is after midnight, 2 a.m. Central Standard Time. And there definitely is a possibility for some surface-based storms within this axis here. That includes DFW, even down toward the Waco area, up into southern Oklahoma. This is that other initial wave that we were monitoring that develops over the hill country to the southwest of DFW at about 10 or 11 p.m., lifts northeast to the mountains and moves more rapidly once it becomes completely elevated, lifting up into the Ozarks by about 2 or 3 in the morning with some thunder and lightning out there in northwest Arkansas. But this convective line down into North Texas is definitely a source of concern as those dew points ramp up just a bit. Let's look at the mixed layer convective inhibition. And look at this. Still a swath here of minimal sin. Let's look at the surface-based sin here. Get a better idea. And look at that, a nice swath of surface-based instability. And this is even 2 or 3 in the morning in the DFW area, even as far south as Waco, when that next convective line comes through. And this is when there definitely is some potential for tornadoes. Even into the morning, even getting close to sunrise, you still kind of have these very favorable photographs here for tornado genesis, even despite the 1 and 2 kilometer winds being a bit more veered out of due southwest to northeasterly direction at about 40 knots. Even despite these veered 1 to 2 kilometer winds at about 10 Z, there still is a chance of a tornado potential extending into the early morning hours out there. Going a little bit earlier at 5Z, this is when that area of storms develops, and you can see that hole here in the convective inhibition, surface-based convective inhibition down here. This is in the hill country to the west and to the southwest of DFW. This is where that cluster of storms initiates too. There you can see it, and these are definitely going to be a source of tornado potential there. Going back to the surface-based sin. Let's try to find a quick forecast sounding or photograph right in the middle of that. And there is some decent surface-based instability. 64 over 63. Due southerly surface wind flipping around to southwesterly. That low-level jet begins to intensify up to about 50 knots. A nice, stout, elevated mixed layer. Pretty high up, too, at about 400 millibars up there. Contributing to some steep lapse rates up here. Some decent cape. A little bit of a bubble of a capping inversion, but seems like with these low-level thermodynamics, you'll be able to overcome that and generate surface-based storms. And this photograph right here is quite favorable for tornadoes. You've got a 1 kilometer wind that's more backed than that last photograph that we looked at. More of a south-southwest to north-northeast type of wind direction at 1 kilometer, near 40 knots. Surface wind due south at about 15 knots. That creates about 20 knots of 0 to 1 kilometer shear borderline for that tornado threat. It is a small tornado threat, but it's non-zero. Then you can see the 2, 3, 5, and 6 kilometer winds way up here, above 70 to 80 knots. More than enough bulk shear in the mid and upper levels to evacuate that rain and the hail from the mesocyclone. Low-level shear, marginally conducive for tornadoes across North Texas with that mode. And really, we got to track this hole here in the convective inhibition. And we'll track it as it moves northeast, so that initial band of storms potentially impacting DFW as well. But you could definitely see some potential for surface-based instability. These holes here, the white coloring, that shows a lack of convective inhibition. By that time, that's at 11 p.m. This is at midnight. The swath continues to increase. That's as that elevated mix layer continues to become more robust and get a little bit lower in the troposphere as well. Definitely the potential for surface-based convection here with a 65-degree surface temperature. The photograph looks okay. It's a little bit veered by this time. The 1 kilometer wind, as that low-level jet accelerates up about 50 knots, becomes more of a due southwesterly direction. Surface wind is also just a little bit west of due south. And that creates kind of a shallow area here for storm relative helicity, but it is marginally conducive for a tornado threat. If you had this storm motion a little bit closer to due east, you get to squeeze a lot more storm relative helicity out of that. You do kind of have this little bit of a loop here, which is irrelevant considering how long these 0 to 1 kilometer shear vectors are. And then the 4, 5, and 6 kilometer winds aloft, more than sufficient to evacuate that rain and the hail from the mesocyclone. So that's the first round that's going to be in this environment out there. Let's look at some of the other parameters. Surface-based cape. That's pretty good cape. So especially for this time in the middle of the night in January, that's a pretty good cape axis here. Cape's 1,200, 1,300 joules per kilogram, feeding north through the Texas Hill Country to the west of DFW. Looking a little further south, I bet the capping inversion is stronger. And not really. But look at all these westerlies at the low levels out there. You've basically got a west-southwesterly wind at 15 knots, creating these nasty photographs further south that just don't support a tornado threat as you go further south, deeper into the better surface-based instability. Even Capes in excess of 2,000 down there to the north of Del Rio, but really weird-looking photographs with all these winds being a westerly direction out there. Very dry, shallow dew points, and it dries off dramatically just above the ground. Interesting soundings down there, deeper into the instability axis. And then at 8Z, it looks like it tries to fire a storm right in the heart of that instability to the west of Waco. But you really get these very shallow photographs further south, and that's why that slight risk is over North Texas into southern Oklahoma. That's where you get those more favorable photographs. These are basically straight line photographs with this loop in there, but they would equally favor a left splitting supercell equal to a right mover. But those are still pretty good capes. A lot of times these in North Texas, these types of events will lead to tornadoes in the middle of the night in DFW, and you can definitely see this cape axis surging north through the DFW area, even after that initial round of renegades lifts north through eastern Oklahoma by this time. This is 9Z, so this is at about 2 a.m. Central Standard Time, and you definitely do have that nice nose of instability lifting north. Man, the thermodynamics, as you'd expect in the middle of the night, are pretty borderline at the surface. So you could get some elevated supercells in this that over the course of the evening try to drill down. But really looking at the low-level shear, it's not incredibly favorable. Even though you've got this 1 kilometer wind in excess of 50 knots, it's so veered by this time, by 9Z, well after midnight, that it does lead to some pretty shallow critical angles at about 30 degrees. That's probably not conducive for a tornado threat, but if you could force the storm motion a little bit further right, you could definitely increase that storm relative helicity dramatically. And those are the photographs that begin to look a little bit more shallow as this main convective line moves through at about 2, 3, 4 in the morning. But from about 11 p.m. to 1 a.m., this initial area of convection that moves through that develops to the southwest of DFW will have some potential for tornadoes to the west and near DFW up through the Red River, far southeastern Oklahoma. And then this next convective line comes through, and there is severe weather, including a tornado threat with these as well, but the photographs look a little bit less favorable when this second convective line comes through. Let's see how it looks a little bit south of DFW. And actually the photographs look a bit more favorable to the south of DFW by about 3 or 4 in the morning. This is not, even though this critical angle is down to 36 degrees, you still have pretty long 1 kilometer shear vectors in excess of 50 knots. It's not the most perfect photograph, but it could definitely squeeze out a brief tornado, especially if you can get some deviant storm motions off to the right. And the day after does not look as favorable at all, that's for sure. But look at how these winds, as these storms develop, this is at 10Z, so this is 4 a.m. Central Standard Time. And see how these 1 kilometer winds, 850 winds, even though they're still at 50 knots, they begin to turn more southwesterly, and that's when those photographs look quite a bit less favorable. The exception being up near the Red River, further north, kind of in the heart of the slight risk. You have some longer 1 kilometer shear vectors in excess of 60 knots. They might elongate that low-level shear vector, and maybe that can compensate for some of these shallow critical angles. But really what I'm looking at is pretty marginal shear, marginal low-level thermodynamics, a storm system that's ejecting in the middle of the night with a relatively unfavorable shape. See how it's sheared out? This is the 500 millibar upper-level system. It's not that nice open wave that you'll often see with the bigger events that eject. This is kind of a shearing out upper level system lifting off to the northeast. It's going to bring a swath of snow right through the Omaha area. I'll show you guys some snow maps as well. But first, let's break down the moisture return with this system. This is the HRRR forecast dew points for right now. And this shows the 65 line down through Austin. Austin should be in the upper 60s by this time. East Texas largely in the mid 60s. So this is kind of your 65 line. And the HRRR likes to show that there are decreased dew points here across the north central Gulf of Mexico, but that's mainly due to the cooler sea surface temperatures out there. You can see some greater dew points indicated by the HRRR. This is basically a skin temperature down there. So it definitely shows the warmer waters over here over the western and southwestern Gulf of Mexico. Those have funneled up the Rio Grande Valley during the day today. Some upper 60s dew points, even some 70s along the Gulf Coast. But let's see how the HRRR is doing with that moisture. The 60s, kind of through the hill country like this, up just south of DFW, down through the I-20 corridor to the south of Shreveport. That's kind of your 60 isodrosotherm. A lot of it getting funneled up through the Rio Grande Valley there. We just had a Chaser Summit call, and Tim Marshall was on the call, and he said they're really socked in with fog right now in DFW, and that's because of this rapid moisture advection that is underway across the state. A lot of stratiform clouds out there as that moisture is ripping off to the north. And now here is the actual surface map. And this is how you can kind of see how well the models are doing with that. Here's Austin, 65 over 64. And by this time, the HRRR had about a 67 dew point in Austin. Just to the southeast of Austin, though, you've got some 70 dew points down there. A couple different 70s, 75 over 70. Upper 60s, though, widespread. Galveston, you're at a 65 right there for some reason. Probably some of those cooler, moderated sea surface temperatures there in the shallower portion of the Gulf of Mexico. And then you can see these 68s surging up almost to Del Rio. You've got a 65 right now in Del Rio. According to this, it did pretty good with Del Rio. 65 exactly. The HRRR nailed the dew point, that moisture surge up the Rio Grande Valley. It does appear, though, that it may be underestimating those dew points just a bit. Actually, that looks pretty accurate as well. Austin has it should be 67, so it is a little bit slower than the HRRR was indicating. But just to the southeast of Austin, you have those 70 dew points as well. So I think that the next hour or so, you're going to see those dew points spike as well in the Austin area. DFW right now is at about 57 to 56 type of a dew point. So it is just being underestimated just a bit. There's a lot of fog. All these horizontal lines there stacked up. That shows that there's a lot of fog. That includes the I-90, I-35 corridor. The front, here is that cold front. Temperatures in the 30s in the Texas Panhandle, and you're about to get elevated convection developing by about 7 or 8 p.m. out there. It's probably going to produce some grapple. Maybe even some sleet pellets out there, who knows. Pretty warm temperatures, though, down in South Texas, but really moderated by this stratiform deck fog out there across central and northern Texas. And it does look like the HRRR is overestimating the moisture return just a bit. It seems to have nailed it down here in the Rio Grande, but kind of the northward push through a large part of central and northern Texas seems to be overestimated by a couple of degrees by the HRRR. So, very rough analysis. It may be overestimating the development of surface-based storms, too, even later on tonight at about 10 or 11 to the west of the DFW area. And that's why you don't want to go all in on the HRRR, that's for sure. So let's look at a couple of these other models, and also let's look at the NAM, the trusty NAM. It's at 9Z. So at 18Z, the NAM has some low 50s dew points in the DFW area. That was a couple hours ago, about an hour and a half ago. Definitely had some low 60s dew points there in the Austin area. So it looks like the NAM may have even been underestimating the moisture return. This is at 21Z. Still has DFW in the mid-50s by that time. Let's go to 6 p.m. tonight. Still DFW in the upper 50s. Even some holes in the dew point field there. Never a good sign. Definitely shows the cold anomalies there in the north central Gulf of Mexico as well. I think overall that's probably going to lead to a later start to severe weather season. So then we go to 6Z. This is at 11 p.m. and you finally can see these low to mid 60s dew points beginning to arrive here in the DFW area. By this time, the HRRR was showing convection there developing to the southwest of DFW, west and southwest of DFW in that axis. And look at the NAM has that big instability down here to the north of Del Rio. Just for the fun of it, let's look at a sounding there. And so when you get into that moderate instability down there in the southern Texas hill country, you can see that the photographs just aren't as favorable. You've got this S-shaped photograph, negative contribution to storm relative helicity here between about 1 and 3 kilometers, greater than the positive contribution to that helicity between 0 and 1 kilometers there. But beautiful cape enhanced by this dry air coming in 3 kilometers and up that causes steeper lapse rates, thicker cape, surface-based instability. You're probably going to get storms down there, but it looks like the left and right splits will be equally favored. Let's see the nose of this portion of the instability heading up into the Texas hill country to the southwest of DFW. A big capping inversion out there. So you really need that trough to eject, to erode this cap, to realize that surface-based instability in the Texas hill country. But boy, do you have beautiful photographs on the NAM. Look at that. Those are critical angles that are about 60 degrees. You want closer to 90, but 60 is fine when you have a 1 kilometer shear vector and 1 kilometer wind pushing 50 knots there. Due southerly surface wind at 15 knots, creating about 15, 25, 30 knots of shear or so. More than sufficient to generate tornadoes. And then at 2, 3, 4 kilometers up, that's where you get the strong enough mid and upper level winds to evacuate that rain and hail from those mesocyclones. So this nose of instability out there could be where these storms develop. And then the NAM expands the instability axis as well, similar to the HRRR after midnight. So this is going to be a late show with tornado potential through about 2, 3 in the morning. But by this time, the low-level jet begins to eject, and then you start to get similar photographs as you see over the southern hill country earlier in the evening with very shallow critical angles near 26 degrees. Some weird action here between 1, 2, and 3 kilometers. If you had a big enough low-level shear vector, then that would be irrelevant, but... So you can see that the thermodynamics are not as favorable with either of the NAM runs, even though you do have 1,000 cape here by 3 in the morning, moving through the DFW Metroplex, looking at a 3 kilometer NAM sounding here. There is a marginal tornado threat with a photograph like this, even despite the slight negative contribution there above 2 kilometers. It looks to me like this 1 kilometer wind in excess of 50 knots, even though it has a very shallow critical angle, should be enough to create some positive storm relative helicity in the lowest kilometer. And as that trough begins to eject, you start to get to drier air coming in here, 3 kilometers and up, steepening those lapse rates. You can see an erosion of that capping inversion by 9Z as well as the trough ejects. Boy, 3 kilometer NAM does not look good. So if you go by the HRRR, I would say there is a tornado threat, but if you go by the NAM models, they may have a more realistic interpretation of the moisture return. And boy, it shows a nothing burger for severe weather through this evening. That's by 12Z, 6 a.m. The front moves through DFW, through about Paris, Texas area. one thing I like to use the high-res NAM for is to look at the location of the wind shear. So here let's look at the storm relative helicity. This is at 18Z right now. This is enhanced by the northerly surface winds out here across the southern Texas Panhandle by 0Z. As that low-level jet starts to increase across central and northern Texas, you can see 0 to 1 kilometer storm relative helicity increases above about 200 to 250. By this time, you're starting to get some elevated storms out here in the southern Texas Panhandle. And then you can really start to see this 0 to 1 kilometer helicity blossom by about 9 or 10 p.m. DFW up through the Red River. Storms could be initiating by about this area and then slide into this favorable environment here for a tornado potential. Most of this, those really strong 0 to 1 kilometer storm relative felicities, though, are enhanced by a decoupling of the boundary layer with these stable surface conditions in the mid-50s. Seems to be, I mean, the NAM is underdoing the moisture return, and the HRRR looks to be overdoing it a bit. Northerly is there, 40, 42. But then look at this. By about 3 a.m., you definitely get a consolidation of that shear. DFW Metroplex east through the Red River region. And this is when that convective line is starting to move through. So anytime you get wind shear that strong, there definitely is a chance for severe weather. But look at that capping inversion. And the HRRR, even though it seems like the NAM has the greater storm relative helicity off to the east, where you'd expect a greater low-level jet above that low-level stability. The HRRR, which seems to be overestimating the moisture return a bit, definitely brings in that low-level wind shear out there right against the immediate convective line. Nice photographs there. So really, my initial interpretation is that this is a marginal event. It's coming into the middle of the night. Unfavorable shape to the upper level system. Decent dew points. Some of the models are overestimating. Some are underestimating. Looking at the surface map, there is it's probably right between the NAM and the HRRR. So one of those solutions, kind of an average between the HRRR and the NAM, is most likely to happen. You'll probably get those renegade convection developing at about 10 or 11 p.m. to the west and southwest of DFW, sliding through DFW up to the Red River. That may or may not be surface-based, will likely be associated with some severe weather. Then the main convective line approaches by about 3 or 4 a.m., definitely with a chance of tornado potential there as well. And there's also a snowstorm potential with this. So we're going to look at snow maps. Here's the latest HRRR. This is the 12Z run, and we'll look at the 18Z and see how it shifts. Well, one thing about these snow maps is if you live in Omaha, don't be too discouraged, because a lot of times these storm systems like to overproduce just to the northwest side. So I definitely think you're going to get a foot of snow in Omaha, a foot out there in Lincoln, maybe a little bit greater in some areas over the higher bluffs and terrain along the Missouri River there. Possibly pushing a foot into the Des Moines area as well. I-80 corridor there. Three-kilometer NAM. Beautiful swath of snow. North central Kansas. These areas where we're normally chasing tornadoes during the storm season are going to get quite a bit of snow. Double-digit snowfall. Even over a foot in some of these areas across northern Kansas, southeastern Nebraska, up through central Iowa, double-digit snowfall totals there. So 10 to 12 inches seem to be the rule. Let's look at the regular NAM. The regular NAM has 16 inches falling in Omaha. It's a 12Z run, so definitely the NAM's picking up on the fact that just on the north side of this swath, there's a very good chance of some greater snowfall totals. Usually these things will overperform on the northwest side. Look at that, Des Moines getting hammered according to the NAM. GFS coming in with 22 inches of snow in Omaha. Look at how, too, it expands that heavy snow swath all the way northwest to Sioux City. Northern Kansas just gets hammered. Southeastern Nebraska all the way into Des Moines. So the GFS has well over a foot, even pushing 2 feet there in Omaha. That's insane. So I would say that a snowstorm is quite a certainty. Omaha through Des Moines, that's where you cover the snow. Concordia, those areas are going to get slammed, just dominated by this thing. And let's look at the long range, because there's a lot of discussion about a system that's coming through at around February 5th in the long range. And I want to give you guys an exclusive look at it here. There it is. And this is way in the long range, but you can start to see that thing gain in strength out there. Big trough. Beautiful consolidated jet stream that you often see with La Nina events like this. This is why these are usually so big for severe weather season, because you get these massive open waves just churning across the country one after another. Big time severe weather downstream of them. And this is going to be our system right here. Look at this backside loaded trough. That is nasty. That is screaming pattern change and severe weather. Looks like it has severe weather written all over it there into early February. Look at that. That's a ski jump configuration, folks. That is an intensifying, dominating upper level system there. That's February 3rd. Oh, look at that. Look at that ski jump. Punch it right into the Southern Rockies. That's going to be a big snowmaker for the Rockies as well. Colorado, get ready. Big snow coming. Big severe weather. This is going to be a big time legitimate system here. All hands on deck type of a system. Multiple days of severe weather, maybe. A lobe of vorticity lifting northeast through the Central Plains. Lifting up toward the Great Lakes, setting the stage, opening the floodgates for the kicker system to come in like a bowling ball down here. Look at that thing dig into northern Mexico. Another kicker system coming into the Pacific Northwest. Something's going to happen with this. It's possible that, well, see how this system in Texas is definitely still dominating this kicker system. It might just kind of shear out and lift up toward the Great Lakes like many of the systems have been doing, but you can see just one after another. Definitely seeing this La Nina pattern just really come to fruition here. But this is the event that we're watching. February 5th out here across Dixie Alley. I'm waiting patiently out here in the Southern Appalachians for Dixie Alley to come alive, but that's what we're talking about. So thank you, everybody, for joining me today for this weather report. This is the situation that we're going to be watching across North Texas. It is a bit of a marginal event right now. I would be chasing it if there was daytime potential of tornadoes. Instead, I'm going to be breaking down radar tonight, and I'm likely going to begin full-blown chase mode starting on that system on February 4th and 5th in Dixie Alley. I'm here at my mom's house on the east side of Dixie Alley, so I can easily access chase mode if need be. But thank you, everybody. Hope you're having a great Sunday, and I hope you enjoy my weather reports. Never stop chasing.